This lesson is on section 7.5, the side-splitting theorem. The side-splitting theorem in a triangle, if a line is drawn that is parallel to one side, so that line is parallel to one of the sides of the triangle, then it cuts the sides of the triangle, this side and this side, proportionally. Okay, now what that means is that the ratio of the top over the bottom has to be the same on both sides. The requirement is these lines have to be parallel. If they are not parallel, the ratio is not going to be the same. The triangles themselves are parallel as well, or it's not parallel, excuse me. The triangles themselves are similar. The smaller triangle is similar to the bigger triangle. So different ways that you can set up a proportion to solve. For example, in this problem, since our lines are parallel, is we would simply set up 16 over 12, the ratio of this over this, has to be equal to that same ratio on the other side, x plus 2 over 15. From there, we use what we know about proportions, and we cross multiply, and we would take 12 times x plus 2, and since you're taking one number times more than one thing, that would give you, you'd have to distribute. 12 times x is 12x, 12 times 2 is 24, and that would be equal to 16 times 15, which is 240. From there, we do our algebra. We'd minus 24, and 12x would be equal to 216, and then we would divide 216 by 12, and we would get 18. The value of x would be 18. Okay. In this next type of problem, that is not what they give us. They do not give us the top over the bottom and the top over the bottom. So you have to understand the diagram over here. There are other ways to set up the proportion. Because of this theorem, there's more than one way to set it up. Top over bottom equals top over bottom is the most common way. It is not the only way. Other ways that you can do it is using the whole sides. The thing with a proportion is that your pieces have to match. So for example, on this one, they give us that the whole left side is x. So we can use the whole left side as one piece of our proportion. If we use the whole left side over, for example, they give us the lower part, we could put the whole left side over the lower left side, but on the other side, we have to use the same thing. So we'd have to use the whole, if we're using the whole left, we'd have to use the whole right, and then since we're using the lower left, we'd have to use the lower right. So using that concept to set up a proportion, we could put x over 5 on one side of the equal sign, but on the other side of the equal sign, we have to put the whole right side. The whole right side is 18 over the lower right side, which is 8. The same concepts apply. We cross multiply, and you would get 8x equals 90, and then you would divide by 8, and x is 11.25. Okay. These ones you set up the same way. There's a couple of ways that you can solve this. The easiest way is to set it up similar to what we did here, where x plus 4 over 2x minus 3 equals 3x over 5x. Now, because they have the same variable, you can just cross them out and solve them that way. The other way that you can do it is to cross multiply. You will get x squareds, and in this problem, you may have to use FOIL to solve it or use the quadratic formula to solve it. Either way will work. For this case, since this is the easy case, I would get rid of the x's, and cross multiply. Then you don't have to worry about it, and you can solve. 5x plus 20 would go on one side, and then 6x minus 9 would go on the other side. I'd minus my 5x, and I'd get 1x, and I'd add 9, and I would get x equals 29. There's a corollary that goes along with the side-splitting theorem. It says if you split a whole bunch of, if there's a whole bunch of lines that are parallel, and you split a triangle or a trapezoid or any other shape for that matter, as long as your lines are parallel, the ratio of the top to the middle or the top to the bottom or whatever has to be the same on both sides. So for example, if I was looking for the value of x, x corresponds to 40. So and 80 is the only side I know over here, which corresponds to the 62.5. So I might put 40 over 62.5 on one side of the equal sign, and then on the other side I would put x over 80. When I multiplied 40 by 80 and I get 3200, then I would divide by 62.5 and I would get 51.2. So my value of x would have to be 51.2. Y, I would do the same thing, except for y corresponds to 50. So I would put 50 over 62.5 equals y over 80. I would cross multiply. 50 times 80 is 4,000, and then I would divide by 62.5, and I would get 64. So my value of y would be 64. The last piece of information for this section is called the triangle angle bisector theorem. It simply says that if you have a triangle and when you draw a segment in that bisects the angle, so this part of the angle has to be equal to this part of the angle, that it also divides the segments proportionally to the other two sides, which means that it cuts the triangle itself in basically into two ratios. So the ratio from x over 12 would have to be the same as the ratio of 10 over 8. And that's because it bisects that angle. It cuts that angle into two equal parts. So we cross multiply and you get 8x equals 120. And when you take 120 divided by 8, you get 15. So x would have to be 15. That concludes this lesson. Your homework for the following classes is right there.